All right, so I'm going to show you really quickly how to run independent samples t-test and a dependent samples t-test on some data here, some dummy data that I've made up to share with you. So I'd like you to focus on the first two columns in SPSS. In these first two columns, what I've set up is data for an independent samples t-test. I have one column that indicates the independent variable, and that is the dose of a drug in milligrams. I have 10 participants in a group that have a 0 milligram dose, that's the control condition, and I have another 10 participants that have a 10 milligram dose of the drug. That's the experimental condition or the treatment condition. In the next column, I have their latencies to reach deep sleep, stage 3 or stage 4 sleep, and this latency is in minutes. So you can see that every participant that's expressed across these first two columns here has both a level of the independent variable, either 0 or 10 milligram dose of the drug, and then also a latency, and that is how quickly they reached stage 3 or stage 4 sleep, deep sleep. Our prediction is that those individuals who received the medication, the 10 milligram dose of the drug, will reach stage 3 or 4 sleep more quickly than those participants who receive just the placebo, the 0 milligram dose. Okay, so that's one example that we have here, and that's for two independent groups. Note that each individual here is either in the 0 milligram dose group or they are in the 10 milligram dose group, but not both. There's one independent variable. That independent variable has two levels, 0 and 10 milligrams, and each individual is only being exposed to one level of that independent variable. I'll show you how to run an independent samples t-test to compare the sleep latencies between the 0 milligram group and the 10 milligram group in a moment. First, let me show you how I set up information for a different experimental design. And in this experimental design, we have participants receiving both the 0 milligram dose and the 10 milligram dose. The first design would have been called an independent samples design, or a between participants design. This second design is what we call a dependent samples design, or a within participants design, also called a repeated measures design, because each participant is being exposed not to one level of the independent variable, but to both levels of the independent variable. So what I want you to do is to focus on columns 3 and 4 here for this design, and just totally disregard what's in these first two columns. That's only for the independent samples design. The dependent samples design is here in columns 3 and 4. So it's a completely different experiment, but I'm actually using the same data values just to show you how to run this kind of analysis. So again, in this design, we've got 2 doses. Each participant is receiving 2 doses of the drug. And because of that, I need to adhere to this rule that participants each get their own row. And so in that row, I've got 2 values for each participant. So participant 1 is getting the 0 milligram dose. Their sleep latency was 45 minutes. That same participant now getting the 10 milligram dose, their sleep latency is 23 minutes. And so I have a total of 10 participants in this design. Okay, dependent samples within subjects design. So the first 2 columns are how you would set up SPSS if you had an independent samples design. And the second two, the third and fourth column are how you would set up SPSS to compare groups using a within samples, dependent samples design. Okay, so these are 2 completely different designs, and we're going to treat them as separate experiments here. I've just put the data in these columns so that you have it all in one place. Okay? All right, so let's do our analysis. We can do a t-test, this is an independent samples t-test to compare our 2 different groups of individuals. in the independent samples design. And in the dependent samples design, we're going to use what's called a paired t-test because each participant has a pair of scores in this dependent sample design. All right, so let's run the independent samples t-test first. I'll just take you quickly through this and we'll discuss it more in class. I'm going to click Analyze, come down to Compare Means, Independent Samples t-test. Now keep in mind, I'm only looking here at the first two columns, and what I've done is I've put the dependent measure, latency, into the test variables, and I put dose as a grouping variable or independent variable, and I've defined the groups here as 0 or 10 because the values in my dose MG are 0 and 10. Okay, I'm going to go ahead and click OK. And I'm looking for independent samples t-test. T is 5.161 with 18 degrees of freedom. And for a two-sided test, this is a significance level of p less than 0.001. This data indicate that there is a significant difference between the 0 milligram and the 5 milligram dose groups. And when I come and take a look at the means, I can see then that the 0 milligram group scored significantly higher. They had actually a longer sleep latency than the 10 milligram group, which had a smaller sleep latency, a lower sleep latency compared to the control condition. So my conclusion here would be that there is a significant reduction in sleep latency for the 10 milligram dose compared to the 0 milligram dose. T with 18 degrees of freedom is 5.161. P is less than 0.001. Okay, so that's the basics of doing an independent samples t-test for a between participants design or independent samples design. Now let's take a look to see how we would run a paired t-test in a situation where we would have a dependent samples design. Okay, so now I'm looking at these two columns. I've got the 0 milligram dose and the 10 milligram dose. I'm going to click Analyze, Compare Means. I'm going to come down to Paired Samples t-test. And what I've done is I've moved the MG0, 0 milligram, and 10 milligram values over here. These are paired variables in that every participant who contributed a 0 milligram score also contributed a score under the 10 milligram condition. So there are pairs of values for each participant. There are a total of 10 pairs. Okay, again, I'm only looking at these columns 3 and column 4, the 0 milligram and the 10 milligram condition. I'm going to go ahead and click OK. I'm going to come down now to Paired Samples t-test. T is 5.547 with 9 degrees of freedom. And again, my p-value is less than 0.001. Since I used the same values in this paired t-test as I did in the independent samples t-test before, the means are going to be the same. So I have a 46.1 mean latency to reach sleep under the 0 milligram condition, and about a half of that, a 23.0 minute sleep latency in my 10 milligram condition. So I would conclude here that there is in fact a significant reduction in sleep latency in my 10 milligram condition compared to my 0 milligram condition, with with 9 degrees of freedom of 5.547, and that is highly significant with p less than 0.001. Okay, so this has been a very quick overview of independent samples t-tests and dependent samples t-tests. Notice that I need to set up, put my data into SPSS in advance, knowing what type of design I have. So the first two columns would be how you would set it up for the independent samples design, and the second two columns would be how we would set up that same data for a paired or dependent samples design. If you stick to this golden rule that every participant gets their own row, you should be set up pretty well, because the independent samples design, if I have 20 participants total, I need to have 20 rows. I therefore need a column that indicates which condition each participant is in, whether they're receiving 0 or 10 milligrams. So I have an independent variable column, and I have a dependent variable column. Dose is the independent variable with 2 levels, and latency is the dependent variable, or the measure. But with the paired t-test, when I have a dependent samples design, I actually don't need a separate column to indicate which condition each participant is in, because each participant is actually in both conditions. They're receiving both doses on different days. Therefore, I just call the column heading, I sort of distribute the doses in my column names, right? So 0 milligrams and 10 milligrams. And then I just put my dependent variable, or my measure, here. Okay, I hope this has been useful. We will cover this more in class, but I wanted to give you a brief video to show you how to set up those 2 different types of t-tests.